So from exercise 2, we saw that if coupon rate was 6%, yield to maturity 8%, and the par was 1,000, your price was $9.47. With yield to maturity of 6%, then the price was 1,000. This is the price you obtained from exercise 1. And from exercise 3, when yield to maturity was 4%, the price was 1,056. So as you can see, as yield to maturity goes down, the price would go up. So there is an inverse relation existing between yield to maturity and price. And let's look into more details. Let's try to compare coupon rate and yield to maturity. So if coupon rate was smaller than yield to maturity, as in exercise 2, you can see that the price, the actual price that the bond is selling at, it's smaller than the par value. Whereas if it were the opposite case, meaning that the yield to maturity was smaller than the coupon rate, then you can see that the bond price, what it's selling at the moment, would be higher than the par value. And finally, if the coupon rate was equal to the yield to maturity, as you can see, the par and the price would be equal. So as you can see from here, the relationship between the coupon rate and the yield to maturity affects the relationship between the par value and the price. So supposedly, let's say the coupon rate is 6%, as in this case. And what that means is, if you invested in a bond with a par value of $1,000 with a coupon rate of 6%, then your coupon payment from this bond, say bond A, its coupon payment would be $60. And on the other hand, if you wanted to invest in a comparable bond, let's say the comparable bond with similar risk and same maturity, that bond B, comparable bond B, and if it were just about to be issued, then its coupon rate would be the yield to maturity at that issue point, which is yield to maturity right now. And let's just think of the case, the first case, with the yield to maturity of 8%. Then the coupon rate for that comparable bond B would be providing you with coupon payment of $80. So which one would be a more preferred bond between bond A and bond B? Of course, the comparable bond B. Okay, so demand will be drawn to bond B and will be just diverted from bond A. So to compensate for that case, for bond A, okay, for investors of bond A, it will have to be compensated with the price. So the price will have to be just sold at a discount. Or another way to understand it, it would be there will be less demand for bond A, that the price will have to go down. So how much down? How much lower? Compared to the par value, because it's, obviously coupon payments have been just decided by the par value. It will have to be smaller than what was stated on the contract, the par value itself. And that's why it's just being sold at a discount. And let's think of an opposite case when the yield to maturity is smaller than the coupon rate. So let's suppose bond A is still providing you with a coupon payment of $60, and there is bond C with yield to maturity being 4% right now. If it were just issued right now, its coupon payment would be $40. So if you're just comparing bond A and bond C, note that the big assumption here is that they are just comparables. So two comparable bonds, one providing you with $60, the other providing you with $40 of payments. Of course, more demand will be drawn to bond A, okay? So more demand in terms of the price will have to shoot up, okay? It will be higher than what is stated on the contract. So the price should go up and higher than $1,000. Okay, so if you just compare the two, price will be higher than the par. So put that all together. First thing to note here is that there is an inverse relation between the yield to maturity and the bond price, just as in chapter 4, time value of money. So time value of money showed us that as interest rates increase, the present values will have to decrease. Just like that, as yield to maturity increases, bond prices would decrease. And also, to give you more specifics, bond prices and market rates move in an opposite direction, in that when the coupon rate is equal to yield to maturity, price would be the same as par value, but as coupon rate it goes higher or yield to maturity goes down, price would be higher than the par value. It will be sold at a premium, and that's why it's called a premium bond. The opposite case would hold as well. So when coupon rate is smaller than the yield to maturity or yield to maturity is higher than the coupon rate, then the demand will be drawn away so that the bond price will be smaller than what is stated on the contract or the par value. So it's sold at a discount, which is why it's called a discount bond as well. So let's just present that in a graph. So once again, bond price and discount rate, which is also yield to maturity, there holds an inverse relation between the two. And to give you more specifics, just like before, let's just try to split the graph into two areas. So this area in the left would indicate that the yield to maturity is smaller than, this being coupon rate, it's smaller than the coupon rate. And this area would be when yield to maturity is higher than the coupon. Okay, so if yield to maturity was smaller than coupon, once again, this is just referring to the comparables payment. So more yield from my own bond, okay, bond A. So it's just sold at a premium, so the price will be higher. How much higher? It's higher than the par value itself. Okay, so if yield to maturity was smaller than the coupon rate, the bond trades at a premium. And if it were exactly the same, then obviously the bond would trade at par. In the last case, if yield to maturity was higher than the coupon, okay, so the payment from this particular bond was smaller than the comparables payment, then the bond, there is less demand for it, so the bond will trade at a discount. So let's take a look at an actual exercise where you are asked to compute the yield to maturity. So all these variables are given to you. 20 years, meaning that 46 months. And then in terms of coupon payments, everything is very similar to what you saw before, but the difference here is that the price is already given, and the price will have to be input as a negative, okay? As we saw before, payments, a coupon price, you are paying as an investor. So 1197.93 as a negative value, and let's just input that in the calculator to compute the yield to maturity. So calculator here, 40N, 1197.93 negative, present value, 50 PMT, 1000 future value, and then let's compute interest IY, and then you will get 4%. So you might think 4% is the right answer here, but as you can see, this was a semi-annual setting, meaning that 4% is the semi-annual rate as well. So the problem asks you yield to maturity, which is of course an annual term. So you'll have to convert it back to an annual term by multiplying it by 2. Because 4% was 1/2 of the yield to maturity. If you wanted to get the yield to maturity, you will have to multiply this number by 2 to have yield to maturity of an annual term. So annually, you will be collecting 8%. The yield from this bond will be 8%. And let's move on to the next topic, which is the inflation and the interest rate. So the interest rate that we have been learning so far is called the nominal interest rate or the quoted interest rate, so R. And this R actually can be decomposed into two parts. One will be the inflation, which refers to the general increase in prices. So you probably have heard of inflation before. And there is what's called the real interest rate. It's the interest rate after adjusting for inflation, which is trying to measure the exact purchasing price, purchasing power, without taking into account the inflation. So in a sense, real interest rate is nominal interest rate after adjusting for inflation. So just taking away inflation, taking away the impact of inflation, what would be the real yield that you would be able to collect. So if we try to just to put that in an equation form, it's called the Fisher effect. So the Fisher effect defines the relationship between the real interest rate, nominal rate, and inflation. If you try to put that all together in an approximate format, then nominal rate is equal to real rate plus expected inflation. Let's just try to do a simple exercise here. So let's suppose we're requiring a 10% real return. That's our objective. And we are expecting the inflation to be 8% down the road. Then what is like the nominal or quota rate? Then R plus H would be 10% plus 8%. So the nominal rate should be 18%. So the last topic of chapter 6 is the determinants of bond yields. Here you would like to see what is the factor for the bond yields, or what is deciding the bond yields. And the first term to remember here is the term structure. So in a sense, what it's telling us is the term of the bond or the maturity is having an effect on the bond yield. And in general, the longer the maturity, the higher the bond yield. Another way to understand term structure is the yield curve, which is a graphical representation of the term structure. So to present it in a very simple format, as noted here, the longer the maturity, the higher the yield, which is a general relation between the two. So your y-axis will be the yield to maturity, and the x-axis here would be the maturity term. And this graph or this relationship can be found in these two websites. So the first website that you can visit is the U.S. Treasury website. And if you go there, it presents you all the U.S. Treasury yields with different maturity terms, like from 1 month, 2 months, all the way to 30-year maturity term. And it's just presented for every day. And the latest one will be found at the very bottom. So as you can see, the shorter the maturity, the smaller the yield. And as the maturity becomes longer, you would notice that the yield becomes higher. And this kind of yield curve, which is just shown in numbers, can be graphically seen in the FINRA website. If you visit there, the graph that you will find will look like this. So it shows you the latest yield for different maturity U.S. government treasuries. And you would notice that the longer the maturity, the higher the yield. Then regarding the yield curve, is the yield curve always upward sloping? Well, in general, in most cases, yes, the yield curve is upward sloping. But the real reason behind the yield curve being upward sloping is because in most cases, inflation is expected to rise, meaning that the economy is in an expansionary phase. If the economy is just going up, then inflation is going up as well, leading to an upward sloping yield curve. But in the opposite case, in some situations, the yield curve can be downward sloping, and it would have to do with inflation being expected to fall. So if you think that inflation is likely to fall in most cases because the economy is going down as well, then that will be reflected in the yield curve, and as the maturity goes up or maturity becomes longer, interest rate or the yield to maturity would go down. Before we finish, I would like to introduce you to one of the resources that provides details about real world bonds that are sold right now in the market. So the resource is called FINRA Bond Center, and if you actually click the website that shows up on the lecture note, it will direct you to the screenshot or a lot of more information, but one of the pieces of information would be the screenshot that you see right now on the lecture notes. And here you can find a lot of details such as the coupon rate and the yield to maturity of the bond, and also what it's being sold at the moment. And here you will have to note that it is all quoted in 100. So even though it shows up as $85.18, it means it's $85.18 of its par value. Most likely 851 for per bond. And
also, it shows like the history, transaction history, the price history of the bond, as well as the credit rating. So you'll be able to find a lot of information that we learned in class about a particular bond that you are interested in. And if we go to this website, this is the page that you will see. And before you find information about one of the bond that you're interested in, please just click this check mark to agree to the website's agreement. And please click the ticker. Please type in the ticker that you're interested in. For example, let's say you're interested in Apple's bonds, then AAPL, which is the ticker of Apple. And then almost all the bonds that are sold by Apple will show up. I'm just going to choose one example, and it will show up all the information that you just saw on the lecture notes, such as the coupon rate, its price, current price, its yield to maturity, and also the price history and everything else.